final word problem. This one's going to be a little bit more challenging, but we're going to look. You are planning an awards banquet for your school. You need to rent tables to seat 180 people. Tables come in two sizes. Small tables sit 6 people. So in small tables sit 6 people, and large tables sit 10 people. Okay, the equation, which is already written for us, 6x plus 10y equals 180, models the situation where x is the number of small tables and y is the number of large tables. Now, if you do not have the equation, sometimes it might ask you, hey, write this equation. Write this equation knowing that x is what it is and what y is. You should be able to write it based on the information you have. 6 people at a small table. X is the small tables, that's where we get our 6x from. 10 people at a large table. Y is our large tables, that's where we get 10y from. And of course, our 180 comes from 180 total people are attending the awards banquet. So that's where we get our 180 from. We have 6x plus 10y equals 180. If you are not given an equation, it tells you how to write it every single time. So now we're going to graph using the intercepts. So to find the x-intercept, we need to put 0 in for y. If we put 0 in for y, we're left with 6x equals 180. We divide by 6. X equals 30. Okay, so when it says interpret the intercepts, I want you to think, when we have 30 small tables, because x's are small tables, how many large tables do we have? 0. We plug 0 in for y. That tells us if no large tables are available, or if the awards banquet just wants small tables, you need 30 of them to sit 180 people. Okay, next situation. Let's find our y-intercepts. Put 0 in for x. Now we have 10y equals 180. Divide by 10. We have y equals 18. Same thing. If the awards banquet is like, I just want large tables, we know we need 18 tables to fit 180 people. Vice versa for 30 small tables, right? That's how we interpret what the intercepts mean. Now you're given your coordinate grid. Sometimes graphing 30 and 18 is kind of difficult, especially when you're only given 10 squares. So for 10 squares, I would recommend probably going up by 3s. Now I'm not going to make you write 3, 6, 9, 12 all the way up because this is a very small graph, right? But I do want you to write something like this. I'm going up by 3s. That way I know that you're going up by 3s. So now I know that each individual grid represents 3 instead of 1. So let's graph our x-intercept first. 30. We know there's 10 total squares. We know we're going up by 3. 30 divided by 3 is 10. That means we are moving 10 spaces to the right. So we're all the way to the end here for our x-intercept. Okay, and for our y-intercept, we know 18 divided by 3 is 6. That means we are going up 6 squares to represent 18. 1, 2, 3, 4, 5, 6. Those are our x and y intercepts. Now all we have to do is connect our dots and graph it correctly. Put an arrow on both sides showing that we are going infinitely in both directions. And we've done it. We've graphed by using our x and y intercepts, and we've understood what the x and y intercepts mean. Okay, now sometimes you'll be asked to find 4 possible solutions for the context of the problem. So basically what this is asking, what are 4 different ways that someone can order an amount of small and large tables to still fit 180 people? Well, the good news is we already have 2 of them. We already have, if they don't want any large tables, we got 30. So let's go ahead and just write it in coordinate form here. We know we can have 30 small tables and 0 large tables. That's one possible solution. Okay? Another possible solution is we can have 0 small tables, which is our x, 18 large tables. Those are two solutions already. Now we just have to find two more. Now you have two options here. You can either A, use a calculator, plug numbers in for X and Y until you can successfully get to 180 in different situations. But that's going to take a while. Or B, we can convert this standard form equation to slope-intercept form. So that's what we're going to do. And we're going to do it up here so that way you guys can see it. We're taking this equation and we are putting it in slope-intercept form. So let's go ahead and do that real quick. Slope-intercept form is written as y equals mx plus b. We haven't talked about graphing slope-intercept form yet, but that's also another solution you could use. But if we're trying to get y by itself, just like slope-intercept form, we have to subtract 6x first. Then we'd be left with 10y equals negative 6x plus 180. Now our final step to get y by itself is divide by 10. That means we have to divide both these by 10. So our slope-intercept form equation is going to look like this. So 10's eliminate, we have y by itself, right? Negative 6 divided by 10 is negative 0.6x. And 18 divided by 10, or 180 divided by 10 is 18, so plus 18. So this is our slope-intercept equation that we are going to use to find two more possible solutions. Now, if we think about it, we can just either A, use this as an input-output table to find two more solutions, or B, we can just plug numbers into the equation to find two more solutions. So that's going to be kind of up to you. I'm going to try to represent this in an input-output table, like we've done in the past. So, in my opinion, the easiest way to get 0.6 to a whole number, because we know we cannot have decimals of a table, right? We're not just going to go up to the company and say, oh, I want 0.6 of a table. They're not going to take a bandsaw and cut the table into a sixth of a table, right? They're going to say, no, that's impossible. You have to order a full table or no tables. So that means we have to plug something in for x to get a whole number for y. The easiest way to get a whole number from 0.6 is probably by moving the decimal place to the right. And moving the decimal place to the right is just multiplying by 10. So if we plug 10 in for x, negative 0.6 times 10 is negative 6, right? So since we have negative 6 plus 18 is going to be 12. All we did was we plugged 10 in for x, and we got 12 out of our equation, just like we've been doing, right? So that's one more solution that we just found. We know that we can have 10 small tables, 12 large tables. Okay, let's do one more. There's tons of different options. I mean, you're not just going to get to one solid answer. If you were to say, I'm going to keep plugging in until I get another solid number, that's totally fine. You can come up with different answers. You don't have to have the answers that I have. As long as you can plug these back into our standard form equation and still get 180 out of it, it's going to be right. But the next one that I would recommend doing, if 10 works, always check to see if 20 works. So we put 20 in for x, because remember, our input is our x, and our output is our y. We put 20 in for x, is that going to work? Well, let's find out. Let's actually solve this equation. So if we have y equals negative 0.6 times 20 plus 18, just like we've been doing, we are plugging 20 in for x. We can put it into our calculator, and we can find that negative 0.6 times 20 is 12. We have a negative 12. What is negative 12 plus 18? Negative 12 plus 18 is going to be 6. So we have two different solutions here, right? Now, I'm sure if you wanted to go in between 10 and 20 and just run this input-output table all the way down, you could find another one where there's two whole numbers. You could. I'm just trying to do what's easiest in my opinion, right? But we've talked about in the past, you can use your input-output table and you can go 11, 12, 13, 14, 15. And if you find two whole numbers, use them. That's completely up to you. I will not count you wrong for that. I just think 20 is going to be the next easiest one. So we know we can have 20 small tables and 6 large tables. So that's going to be our fourth solution. So those are our four solutions. We can have 30 small tables, 0 large tables, 0 small tables, 18 large tables, 10 small tables and 12 large tables, or even 20 small tables and 6 large tables. Those are the four solutions that we can possibly find. Again, we can probably find a few more than that, right? Of course, if you have any questions, please email me or ask me in class.